Hi everyone, welcome back. Hi everyone, welcome back to this channel. You might have heard that companies talk about or YouTubers talk about that about microservices where many big companies use microservices such as Netflix, Uber and Amazon, and sometimes why your own project or if you are a startup company, if you hit 1 lakh users or 5 lakh users or 10 lakh users, and then suddenly it's impossible you to scale up at certain point if you are using the monolithic architecture. And that's where we are going to talk about today, related to microservices architecture from the ground up. So we are not just going to talk about this, but we are going to actually understand why it actually exists. And also we are going to compare head to head with the traditional monolith approach. And also, like, I'll walk you through the pros and cons of using monolith versus microservice architecture, honestly. And then and also, like, what are the components that use in the microservice architecture, such as REST, gRPC, and then Kafka. And in the end of the video, you would understand that what all the microservice architecture is, and then what is monolith. So let's get started. Now, when you are building a product, let me take my pen. Yeah. When you are building a product, it basically there are two approaches. One is microservices, this one, and another one is monolith architecture. So what exactly is monolith architecture? Let's say you go to a buffet and you take your plate, and then in your plate what you would do is you can take some biryani, two chapati, raita, and then sweets if there is any, pan, ice cream, and then some mixture if there is any, some savory, and then some rice, curd, dal, sambar, rasam, everything you put it into one plate. In monolith, what happens is you put user management in it, and user management, session handling, and then product related information, order related information, uh, front end, back end, and database. Everything you put it into single server, and you try to use this for your service. Now, if you look at microservice architecture, what happens is you differentiate, like if you go to a normal restaurant or big restaurant, for example, you order only whatever you want. Let's say you want biryani, you only served with biryani. Let's say you want uh, roti with butter chicken, or you want curd rice, you only served with curd rice. And if you want ice cream, they will only serve you rice. Now, exactly in this example, whatever we talked about, exactly in the real time, what happens is you differentiate the services, like user service, authentication and profiles. You put it into a different server, and then you use it. And the product related information, like how many products we have, how much inventory we have, what are the stock, how much stock do we have left, and order services. In the order service, what you handle who is ordering, like is it in checkout page, is it in what do you call this one, uh, 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 add to cart, and then checkout page, all those information you differentiate. And then finally payment page, you put it into another one. Once that is done, what you will do, you go to third party page for the payment related, such as Razor Pay, and then you put it in a separate thing for notification section. Once you place the order, you get a notification saying that your order has been placed, and also you get a WhatsApp message saying your order has been placed. Like, so you understand that instead of putting everything in the one server, all your services, and deploy it into one server and serving for all the users, you segregate, you differentiate which goes under what, and then you try to do this. So that's where this microservices architecture comes into picture. Now let's move on to another page. Here, see, one big app that does everything like this one, and versus small apps to each do one thing and talk each other. Now, how it will talk to each other, I will make you understand in the next slide. Let's move on. So here we already discussed about this microservices versus monolith. You see, in the monolith architecture, you have users, products, orders, everything into one place. You also you have only one code base. In this code base, what you will do is front end, back end, if there is any, if you have mobile app also, all the mobile app related code, and the database, and for caching you use caching DBs, everything at one place. See, one database, one deploy, even you put everything into one place. Whereas in microservices, what happens is you differentiate users information into one separate database and one separate thing, and products also same thing, orders also same thing. You see, every architecture conversation starts here. Understand this comparison like REST, gRPC, Kafka, decomposition will make a lot more sense. Now we'll understand what that is here. Let me scroll this up. See, as I said, all the features live in single database. Let me, yeah. So all the features live in single code base and ship together. So it's very easy to deploy something if it is a monolith architecture. It is very simple to start. If you are a startup owner, if you are working on your own startup, then creating a monolith architecture is very easy. So one repo, one server, one database, one deployment. That's it. So if there is any bug in the search functionality, let me show you with an example here. Now imagine in the Amazon portal, if a search engine, the search option is not working, but you are able to navigate through this section. Let's say you want to toy bestseller, you want to buy any Amazon products like Echo, Alexa, Kindle, even you can buy mobile phones, everything you can click on here and then you can navigate through. But in the monolith architecture, what happens is if there is any bug in here, that's it, entire app will crash because your entire code base sitting in one place, and then if something goes wrong, your entire system will go down. Let me take my pen again. Yeah, your entire app will go crash soon. To handle more traffic, what you have to do is you have to take down your entire application, and then you have to scale up, you have to spin up more servers and accommodate them so that users can use it. So this is only used for small applications, as I said initially. So Once your user base is increasing greater than 1 lakh, then definitely you have to move to the microservices architecture, where you have to segregate different sections, user sections one thing, products different. See, each service owns one job and one database. So this will have one database, it will talk to that only, and this one, and then now synchronize with these three things using the technologies like gRPC, Kafka, and REST. That we'll talk in the next slides. Team deploy independently. Say you want to now, in Amazon the search option is not working. You don't have to take down your entire application. You just go and open the related microservices and you fix it, and then you deploy that alone. Meanwhile, the entire application will work normally only. There won't be any downtime. So a crash in notification doesn't take down the checkout. Now see, as I told earlier, that once you placed your order, you get a notification saying that, hey, your order placed, right? If that is not working, what goes wrong? We are going anyway, we are going to display the order information in the website itself. Once you fix your bug, you can send this notification, whatever pending in the cron job, you can trigger them later. Now scale only what's under load. Now there is a page section, there is some you put an offer for the new mobile phones. Instead of giving scale the users information, order information, you directly procure one server, spin up one server for the mobile phone section itself. So more moving parts to monitor, deploy, and coordinate. This is very useful if it is a large application. Let's move on to the next slide. So what are the pros and cons using microservice architecture versus monolith? Now let's talk about it. See, in the world, nothing is better. Okay, it's all your requirement, whatever best suits for your application. Okay, there are two different trades of. One will use for one monolith will be useful for some people, some application. Microservices will be useful for one application. There is always a trade-off. There is a good, there is bad for everything in this world. Now see, monolith, simple to build and deploy, that we discussed. One code base, one database, and it's very easy to deploy each and every time when there is a new feature that you are working on. Easier to end-to-end testing since everything runs in a one process. Without testing, you cannot going to deploy. If there is any bug in your application, if there are repeated bugs in your application, you lose the faith, you lose the trust from the users, and then user easily move to some other application. But here, this is a good thing for you. Lower operational cons, no service discovery or disrupted tracing to manage. So what does it mean actually? Since your application is very small and you are running a single server, it's very easy to if you want, you can procure a new server, whereas in microservices you have to pay a lot. So faster for small teams and move quickly early on. No network calls between components. So this REST API calls, gRPC calls, and then that the other service that we talked about, that doesn't require here to talk between the both different services. That is not at all required. So cheaper to run on small scale. Now, what is bad with the monolith? If there is any bug, your entire app will crash. This is very bad. Scaling is all or nothing. If you want to scale your application, you have to scale for all the services, all the features you have to scale. Otherwise, you can't able to do. Code base goes larger and tangled, making onboarding harder over time. So you keep on adding features to your application. And at one point, what happens? Your code base will become bulkier, heavier, and it's very hard to manage. Slower deployments. One, a small change means redeploying everything. as we discussed, that if there is any problem in any of the service, any of the thing, then what you have to bring down the application and you have to redeploy entire thing. Hard to multiple teams work independently without conflict. There is always conflict because you only have single code base and the technology lock-in. So now you are using for front end you are using let's say React. For CSS, you are using Tailwind. For backend, you are using Java. And for database, you are using Postgres. Now, if it is monolith, you are locked with this only. Whereas in microservices, you can choose anything. Now, let's talk about them. Let's move on. Pros and cons for microservices. Here is a one. Let's talk about them one by one. You see, it's independent deployment. Ship order service without touching the product service. Now we have seen earlier, orders thing is different, product services is different. If you want to do any change to product service, you can only take down the service and then quickly you deploy the change whatever you're looking for. Fault isolation. Notification service crashing doesn't break your checkout. This also we discussed. If something broken, your app will still run and then it won't break down. Next, targeted scaling, meaning you want to see some load in one of the page, then one of the service, then you can increase servers for it so that you can accommodate. Teams can use different tech stacks. Yeah, that is possible. Say, for example, in the front end also, front end or back end where the for the product service you might use Java, but for the shipping order you can use Python as well because these are independent now. It is completely decoupled, but talk to each other all the time. That is possible. Easier for large organization to split ownership across teams. Yeah, so let's say as Amazon like company, some people work on payments, some people work on order related things, some people work on notification things, some people work on Amazon Pay section, and like this. Smaller focused code bases are easier to understand. Now, if I assign this, there is a bug, go and fix it, then what you will do? You directly go to this microservice, payment related microservice, and you look at the code base, you understand, and you will try to fix where the problem is instead of looking into entire code base if it is in monolith. Now, what is the cons? Since you are segregating into different services, there is a much higher operational complexity, meaning you have to handle network discovery, monitoring across services. Uh, you have to procure a different monitoring service such as uh, Datadog or yeah, many things. So instead of that, it comes with a lot of cost as well. Distributed system problems, there is a latency, you have to handle that. There is a partial failure, you have to handle that. Retrace, eventual consistencies, you have to handle all those things. Harder to debug, one request may touch 5 services, so tracing need to real tooling. Now if there is one service that is talking to 5 different services, now you have to handle that. Where actually the problem coming? You have to go and check each and everything, right? Data consistency is harder without a shared database, right? Now everything is having different databases here. Now you have to look into, if you want to check something, it's difficult. See, I'm saying it is difficult if you are working, if you know each and everything about the application, if you are a full stack developer, you would understand where it is going, what it is happening. Until that point, it is difficult to manage. Now testing is more complex, need multiple services running together. Let's say you are doing end-to-end testing and now notification is not working. You are running some automation scripts and suddenly notification section not working. Your automation testing will stop, or your manual testing also. If you are doing end-to-end, definitely it will stall because Some of the service is down, you have to wait until it gets fixed. More infrastructure, meaning cost. And DevOps team also, you require the Kafka, orchestration gateways, many things. Overkill for the small, if it is a small project, then it won't work here. That's why always a trade. There is always a trade, like trade off, like which works for you. And let's move on to the next section. So there is a thumb rule, right? Like if you are a startup company, you have to start with small and then uh, ship your features and then get your audiences or the users quickly. And then once your business is scaling, you can slowly move from monolith to uh, microservices architecture. And now let's look into service composition. Now see, decomposition just means deciding where to cut the monolith. Now you are a startup owner and your business is scaling. Now you have to understand where to cut your app so that you can move from monolith to microservices architecture. The thumb rule is split along business capabilities. As per the business, you have to do it, not as per the technical layer all the time. You have to remember this. What is the service responsible for plain English? You have to put it, you always speak in plain English and understand which is impacting what. If the answer needs the word and, if always like if this service required and let's say your notification requires first order and then you have to go to notification section, then definitely order is different, notification is different. See, in the monolith what happens, users, products, notification sections, repayment, order placement failure, and then replacements or returns, reorders, everything will be one place. Whereas in microservice architecture, you put differently. User service, who is the person, what is he looking for, what are the products he likes, and if it is a product, then definitely what he want to buy, how many they want to buy, what is the product description, how many products do we have left, all the information will go here. And then order service here, what they want to buy. And then once that is done, payment information. And once that is done, this transaction related information, that notification section, everything will go here. Everything will have a different DB. No shared database. That's the whole point. Now let's move on to the so now you have moved from monolith to microservice architecture. What are the different things here? Now gRPC means Google. Uh, give me 1 minute. Yeah. So now see here, once you separated your services, you came from monolith to microservice architecture, they need to exchange the information. Like he has moved from user is trying to do something, and then he selected a product, and then he moved to product section, and then he moved to payment section, he ordered the placement. So all these things, it has to talk to each other. It has to talk. So how the talk will happen? There are three common patterns here. Think like them, different ways people communicate. You can communicate through phone call, you can fast internal walkie-talkie, and then bulletin board. You can do in that way. So this is the common thing that the people use across the software industry. This is the universal approach. So one service sends a HTTP request, and then it waits for the response. Once that is done, it will send another HTTP request. Use it when front-end mobile app talks to the backend, or when simplicity matters more than raw speed. So you don't want quick thing to happen, but you want things to happen in a sequential manner, then you go to REST. Then there is another one, gRPC, meaning Google Remote Procedure Call. So here the services call each other using the compact binary messaging instead of text. So it uses JSON format, and then order service needs to call product service internally many times in a second. Speed matters more than the human readability. Since it is in JSON format, you can't able to understand. It will change so later when it is coming to you. And then later Kafka. Kafka is event driven, the bulletin board. So a service posts an order placed, a stream. It does not know who reads it. Once this other service are subscribed, react whenever once they are ready to read. Use it once the action should trigger. Several independent reactions such as an order place should be updating the stock, notify the user immediately and start the shipping it, and then without those service backlog to talking to each other. Now let's move over to the next section. So this is some of the examples that how we build using the services. Let me quickly walk you on this one. See, reading about microservices only get you so far, but there are something like these are the different services you can differentiate, like user service. In the user service, what will be there? Sign up, login, profiles. In the product section, you have catalog pricing, and the stock and the order information. You have cart, checkout, order status, everything like this. And then in the wiring section, what you will do? Connect to all these three using, if it is REST, what you will do? You will talk only with the front end with the order service. If it is gRPC, order service, product service, check out the stock fast. If it is Kafka, then what you will do, once the order placed, immediately you send the confirmation to the user. And now you are going to verify if everything is done correctly or not. Trace the request end to end. Place a test order and follow it through the system. So this is how it works. Now let's move on to the another page. How Amazon actually does. So this is the real-time example that I already showed to you. See, so Amazon.com app, there is an API gateway. If it is REST API, what it will do? It will REST call. What happens? This account's address from it will take this information from user service, and then it will take the product information, price, stock, catalog, what are the different items available, and then with using gRPC, what it will do? It will update the card information. Now event gets triggered, it immediately goes to notification section, and notification service send the notification to the user, and then it will immediately update the inventory. Like that it happens. And the final one, and see, this is how it happens. Now I hope you understand the different things in what is monolith versus microservice architecture. Thank you.